All right. So yeah, it's been a while. Last time was I just kind of spent I just wasted time last time. Just I mean not waste, but I guess waste for the viewers. Like reviewed the just reviewed old prior work and then off stream like over some weekends I just basically rewrote it except like with some changes to support new code. Like I could have just like kind of cherry picked the commits and just kind of like or like kind of used existing work like verbatim and then like fix the compile errors because all the numbers have to be replaced with our fixed point class. But no, I did not. I basically kind of like took this opportunity to kind of like build it from not really scratch, but like kind of build it like a clean rewrite, basically using that for guidance a little bit. But yeah, also using replay for guidance. But okay, let's just kind of like start. So like, what do I actually have, right? Let's just actually start off with like the. I think I have it running. Okay, I guess it's not running. Let's just create a server. I mean, sorry. Let's just kind of kick it off. Full screen. So basically, well, actually no. Let me just start off with a. Let me just start off with a demonstration, right? Okay, great. So now it should be running. Yep, three servers: the game server, front end, and matchmaker. And let us actually like. So we have a bot, right? It's making random moves. Like it's just randomly selecting a coin and making a move. And it is doing it legally. Like it's not cheating. Like it's not spamming moves and violating any energy system constraints. No. It is launching a move at 40% of max intensity and then it's recharging until the bot hits full health and then does it again. In fact, I think I have like the some how do I more tools. Like it's never mind. But anyway, so like we basically we just have a bot that's just like making random moves right now. And the point of today's stream, I guess, well, is to like currently we have code that randomly kind of generates moves and we're going to replace that with a neural net, just like we did for Connect 4, right? Like just it's the exact same principle. Just start off with like kind of this is like kind of like the harness, like the just the glue just like the a starting point, like skeleton file, and then or like basic implementation of a random bot, and then we're just going to swap out the function that selects moves from random to a using a network, and that's the goal. So I guess first of all, I guess after I play this game with this bot, like just to demonstrate this like bot web page working, I will get started with actually like so first I'll like play a demo game with this bot, and after I play a demo game, I will just review the code a bit and then begin actually integrating the network into this game. So let's start. Let me just quickly make quick work of this bot. Okay, so yeah, it says you have defeated the bot. You can, of course, do a rematch if you want. Like, let me just have the bot beat me. Just to like show both outcomes. I doubt I can show a draw. Gee, why am I hitting so hard? I can hit softer. Wait, this is a waste. Let me actually like kind of engage with some coins. I'm trying to like make it bounce off the obstacle and hit me. No. Okay, forget you, coin. Oops, that was not correct. I'll stay here. Oh no, it's going away from me. Yep, you were defeated by the bot. And then once you're finished rematching, you can just click exit. It'll take you to the home page. So that's basically where we're at, right? And additionally, there's some files like model, yeah, .json. I guess it's suggesting it from Connect 4, but cannot get model. Oh, sorry. It's just this way, like that. Like, and I also kind of copied in like, I just CP'd the net, like the dummy network or the initial network from the BumperCoins bot repo that we were working on for the past few streams. So anyways, so that's kind of like a brief overview of like where we're at, like, and then let's actually like have a look, right? So ls, like, let me like actually show the reverse command, right? CP into the BumperCoins bot directory. It's a sibling of this one. Like the parent is my home directory, and then BumperCoins bot, and then model, and then this command to get like all the contents, namely the model.json, and then the weights.bin, and then copy that into front-end client, right? So if I do like ls front-end client, you'll see a lot of things. Let me highlight the main ones that have been added. So there's the model there's the model, and then which we just actually saw in Firefox. We opened it up, and then there's the weights. Again, these are just like the model and the weights. I have only copied it. I've only run that CP command. I have not actually like used the bots. That's the idea for this stream today. The idea for today is to actually use these weights and use this model together to kind of in our web worker, use a network instead of randomly making moves. Of course, right now they're synonymous with each other, but I guess I'm curious to see how long it takes for the network to make a prediction, and that's actually kind of crucial. In fact, I probably should have done that even before doing any work. That should have probably been the first order of business, actually, to make sure it's feasible. But a few years ago, I tried it, and it seemed to be feasible. I think it took 100 milliseconds. I'm sure it's going to be faster now with improved hardware. But anyways, so those are the two files that are, those two files are, what do you call that? They define the neural net. And then let's search for the model page, or the bot page. Then we have, well, forget this. So we have bot.css and bot.html. So those are like just the standard, like the web page, like that's the styling, and that's the web page that we just saw. And then the JavaScript that's linked in this thing is found right here, is like the main JavaScript file, bot.ts. And then we have also bot.worker.ts, which is the web worker that actually that we're going to like work on today to integrate the neural net, the neural net inside this bot.worker.ts. Okay, let's just have a brief look at our main. We'll start off with the HTML. Okay, so that's just CSS, just pretty standard stuff. And again, like we can view it right here too, like no big deal, right? Then here's the next one. And then here's the HTML. Just so let's kind of look at this. So just some header stuff. We have the container. We have a canvas because everything is rendered. The whole game, this whole thing is just like one big canvas right there. And then there's a game over pop-up wrap, which like you saw, like when the game ended, like there's like some information in chat content, like stating either the you won or the bot won, like it states the outcome or it's a draw. And then there's two buttons. You can kind of do a rematch, or you can just do an exit. So yeah. And then there's to be honest, I don't know why we have wins. There shouldn't really be any need for wins because currently I just copied this off of either the replay HTML or the game HTML. I guess maybe I can delete this because there's no need for wins, or maybe draw references it, and then some sounds. And actually, we're not using the sounds, by the way. They're just there from copy and paste. But the main thing is the script right here, the minified version of bot, which is bot.ts. So let's have a look at bot.ts, right? Actually, let's just kind of open all of them. So this is bot.ts. This is like the main JavaScript for that the bot page uses. So let's kind of go over this. And again, a lot of this is quite similar to what I reviewed last stream, except I think I may have cleaned some stuff up. And also like we're using a fixed point now, which is, yeah, this whole new thing. So, okay, ignore this WebSocket stuff. It's kind of like, we're kind of like just creating this like mock function. Like, don't worry about that. It's just a way to like this is basically lifted from the actual game where like the client, like, I mean the player like moves the mouse, and like when the mouse like kind of like when the client decides to like send the move to server, it basically sends the move. But now we're kind of like, I guess, intercepting that. Like we're intercepting sending it to server. Instead of sending the move to server, we're just basically applying it. So like that's how like the human applies the move. So this is just like, yeah, don't worry about that too much. So basically we have like when you click the restart button, or when you load up the page for the first time, we're going to call restart. So when we call restart, like we call it right here, when we like, the first thing we do is we call restart. So what does restart do, right? So first we close any pop-up wraps. We just, okay, let's just skip all this stuff like cosmetics and like some like mouse coordinates and like handling the move. But like the main line in this thing to kick off the game really is this function right here where we kick off this interval loop every, I guess 16 FPS. I mean 60 FPS, which means each tick is 16.66 milliseconds. And we basically are constantly doing updates. So that's like the workhorse, like the heartbeat, this update function, right? So update is this loop right here, update. This keeps looping on until the game is over. So update, we update the game state, we do refresh, and then we increment our tick number. We're just counting the ticks. Then if any of the player's energies are less than the full energy, we just like increment it by 1. Then we just do some nonsense here, and then we just draw it. This line shouldn't be needed, actually. Like if I refactor drawer, I put a to-do comment on that. And then this line we're probably going to change in the future, the if condition, but like basically like, okay, so like if there's no in-flight move, like we haven't queried our bot for a move. Oh yeah, sorry. Let me go back to the restart. Another crucial thing is this right here. We basically launch a new bot worker, right? Which is like the next file, which we'll get to. So that it's not like single threaded, or it's like, we don't want to like, okay, here's how we message pass to the bot. So like, in this loop, like we have like kind of two main kind of bot messaging functions. One is to ask a bot for a move. And then the second one is to handle the move that the bot gives us. So where do we ask for the move? Well, we ask for it in the update, right? Which I was just talking about. In the update function. So then like right here. So then if there is, if we haven't like in progress moves, like whenever we ask for the move, we set this flag to be true. So as long as there's no in like as we don't want to double ask. We don't want to ask the bot for a move and then ask it for another move and then execute the move. We want to ask the bot for a move, get the move, execute it, and only then can we ask for a new one. We don't want to double ask, basically. That's why there's Boolean flag. And I just said that like as long as the energy is greater than or equal to full energy, we're probably going to change this line in the future. Right now, we're just kind of, just to get it to work, but in the future, we're probably going to have something different here. But what this is saying basically is if we're full energy, then let's make a move. After making the move, we'll lose some energy. It'll take some time to recharge. And then boom, we can make another move. So this kind of like gives it the rhythm. Like this. So anyways, it gives it like it's just the cycle, like the bot loop. So if these conditions are met, like we're ready to make a move, then we ask the bot for a move, right? So we ask the bot for a move, and then in the next file, we'll see how the bot randomly selects a move. But once we get the move, and of course, if the game's over, we just kind of handle game over, which kind of ends clears the interval and kind of like just opens the pop-up. But anyways, so like once we ask the bot for a move, like you may wonder, like how do we actually like receive the move, right? So ask the bot for a move, and then like the bot somehow like we get the move changes the game state, and then this reflects. So the only question now is how do we process the move for the bot? The human process move is actually done here anyways. So when we get the move, like that's where the WebSocket comes in. Like, oh wait, sorry, no. Where's the on message? Yes, right here. So here's like the binding. Like when we kind of load the bot worker, we kind of like attach a handler to it, which is handle bot move. In handle bot move, basically again like. So like notice like the same Boolean sets to true and then sets it to false. We used like this Boolean to again, like I said, like don't double ask for moves. Only ask, then execute the move, ask, execute, and keep it like, yeah. So anyways, so like when we get the move, well, we logged it, and then we're computing how many ticks it's taken. Because like I'm curious to know how much time how many ticks the neural net takes. Like right now it's basically instantaneous because we're just randomly selecting a move, but like when the actual neural net runs, it'll take some time to actually make a prediction. So this number might change, so we may have to do a bit of work for that. In fact, in my notes, I have some discussion about that concept of like why we need to store the ticks. I have like a hypothetical I wanted to use a whiteboard to show, but I guess this is actually beyond the scope of today, maybe. Right now we just care about integrating the net. But yeah, so where was I? We get the ticks, okay, fine, we print it out, sure, and then apply move. And then we set this Boolean to false. So apply move is the heart of everything, applying move. This apply move, right now, this is how we handle bot move. But how do we handle like the human move, like when we make a move, right? Well, same function. If you look at our mock send, which it also uses apply move. So apply move is both for the human and the bot. Like both parties use the same apply move, and apply move like does the clamping. It makes sure that like it's a fair game, and we're not trying to cheat the energy system. And if we do try to cheat it, it'll scale our stuff down. And this is actually copied from a lot of the logic is actually, well, there's no validation logic because like it's a static file. Like this whole thing, like TSC compiles it into a static file. So like if you want to cheat against the bot, I mean you could, but like you're not like cheating against another player. Like it's all client side. Like it's just like a few files. It's static. It's not dynamic. So that's why there's not as much validation as there is in the actual BumperCoins game. But basically like there's just like some clamping. Like you see like this notion of adjustment. We're just like kind of scaling things down. Like, hey, like if we're trying to like launch, if we're trying to launch like the move, if the velocity of our move is greater than the max move, like max allowed, we're going to scale it down basically. And then if the move we're trying to do, its energy cost is greater than how much energy is actually available. Again, like we're switching on the player. P1 is human, P2 is bot. That's just the convention we're using. humans will have gold coins and be on the left, and bots will have silver coins and be on the right. That's just the convention I arbitrarily chose. And again, like if this the energy cost is too much, like the move consumes too much energy, like let's say we only have like 50 units of energy, but the move cost is 100, then what do? We take the move and then we scale it down by a factor of 1/2. We scale it down, like cut it in half. This adjustment kind of computes this ratio of the energy available divided by energy cost, since it's like 100 divided by 50 is 2. So we basically, we divide 100, no, available is 50, energy cost is 100, so like this becomes a half, and then we basically multiply the Vx and the Vy by 1/2. So you basically scale it down. So like that's kind of like this notion of like clamping down. So like since everything ultimately uses apply move, it basically enforces that we're playing fairly. So yeah. And then just the starting game state. And one thing I'd like to point out, I basically kind of copied this from our in the BumperCoins bot has a function that creates like the constructor of the what do you call that? The game state, like kind of does it. And like this whole mirroring coin stuff, I kind of realized that there was a bug in my BumperCoins bot, like when I kind of like did, I think like this, like mirroring the coins and also mirroring the obstacles O2, where it's like kind of like 20 minus the X, I guess with the offset of W, the width. I actually realized that, actually, let me just actually briefly show the changes I made. So here are like these two commits, fixedpoint.clone, which like these two I did off stream. Yeah, in the game state constructor, because again, the game state constructor is where you like kind of like, it's where BumperCoins frontend client bot.ts. So like when we're creating the game starting game state, like I basically kind of copied and pasted the constructor in the game state, but for the BumperCoins bot folder, like you see this constructor right here. Basically, like when we're kind of taking the P1, like here's the constructor, which like we did this on stream. We like, yeah, like this whole mirroring thing. I actually did not have fixedpoint.clone. So like this fixedpoint.clone was missing. And likewise, when we're kind of like flipping O1 to get O2, I was missing this fixedpoint.clone and this fixedpoint.clone as well. So I basically did that. In fact, is there a way to do that? Git diff. Git diff head, maybe this one? Does this work? Yes. Okay, so here's the diff. If you look at like this line, everything is the same, but then here, everything is same up till here, but now the CY basically, sorry, I got the order wrong in the git diff. Let's just clear it and then redo that. So okay, so like there it was just like this is what it was like, and then I basically kind of like added in the fixedpoint.clone. I wrapped it on this c.y. Because again, like when we're mirroring it, we don't want to point to the same fixed point object. We have to actually do a deep clone of it. And I guess like it didn't seem to matter, because like many of the fixed point, actually all of the fixed point arithmetic operations, like if you do a plus b, like if you do a equals a plus b or something, then like a plus b does not actually mutate a. Instead, we're returning a new result. So like fixedpoint.add a comma b, it does not mutate a. It actually generates a new number, a new object. So that's why I don't think, never mind. So I'm saying that this might not be, I mean, this is part of the correct way to do things. You want to clone it. You don't want to point to the same object. And likewise, same thing for obstacle. Like everything is the same up till right here, where the O1.y, so the obstacles, it's y coordinate and its width and height basically all get like cloned. So okay, so that's the changes that I made in the BumperCoins bot folder. So back to BumperCoins. So okay. So I think this is all. So the main thing right now is how do we actually get the move, right? Like when we're like we're asking the bot for a move, we're kind of like doing a post message on the game state, and then we're saying like in progress move marking that as true. So we're giving the worker thread the game state. So here's the next file, the actual worker thread. So here's a worker thread. When we're kind of passing in the post move on the this events data as the game state, then we first kind of take our game state. I guess we could just inline this and just kind of copy this, just paste it there. But like we basically retrieve the game state from what we passed in this worker thread, and then we just call get move on the game state that we retrieved. We get the move, and then we post message to pass back the move, and then the game applies it, and then computes how long this whole thing took in terms of ticks, and it prints out the move. So ultimately, get move is what we want to do today. We want to replace get move from being random to using a neural net. And again, the neural net right now I think is the same thing as random. But anyways, so right now let's look at get move. What does get move do currently? First of all, we have to get, again, humans are player 1, bots are player 2, right? So then first we need to get the actual coins. And that's what this does right here. It gets all player 2's coins. False means player 2, true means player 1. So then we want player 2's coins. And then we just randomly, that same random trick, we just randomly get like math.random between 0 and 1. And then we just kind of get a random coin from the bot coins, a random player 2 coin. And then we randomly generate an angle between 0 and 2 pi, which this does. And then again, the usual thing, we get like the cosine, negative sign for the axis. I don't think the sign really matters because it's random angle to begin with. But anyways, just keeping it consistent with prior code that we've seen. And we've already talked about this when we're looking at like the move directions or number of move directions from 0 to 7. So 8 move directions. Like we did the trick there in a prior stream. I basically copied and pasted that code. So right now, dx norm and dy norm are just a unit vector. A vector of magnitude 1 of a random angle. Again, like cosine squared theta plus sine squared theta is 1. Therefore, so therefore it's a unit vector. The 1 is 1 squared, right? A squared plus b squared is c squared. C squared is 1, so c equals 1. Plus or minus 1, but 1. So then what we do is we basically like take our vector and we scale it by this number for both the x and the y components. And then we return like a move with the random coin we selected, and then this new scaled vector. So the highlighting is what we're scaling the unit vector by. Well, let's look at this. Fraction of max launch is 0.4. We're going to launch the coin at a little bit less than half of full strength. And how much does full strength consume? Well, how fast is like the maximum? That's just in this number. Launch max velocity. I guess I converted this to number because everything else is number so far. So yeah, this basically generates a random move, and it is at 0.4 of the max velocity. So it's a bit less than a full strength move. We've already talked about this in like one of the early streams when we started off going back to BumperCoins from C4, Connect 4. Okay, so now we just want to kind of like load up the neural net, right? So let's actually, I feel like going back to Connect 4. Let's actually look at the source code for Connect 4. Oh, sorry, source code. In bot.ts. or no, sorry, game.ts. Game.ts. Let's search for await. Yes, so right here, await tf.load layers model, like that. And we're gonna have to copy, yeah, so we're gonna have to copy in BumperCoins bot net.ts to convert the game state into an image stack, right? Let's copy this line right here. Put in line 1. And let's just make that tf.js. Like that. Okay, so we have TensorFlow tf.js, and then what do we need? We need to kind of create the model or load it. Function load or async. How do I do it here? Async function. Sorry about that. Load model. Let's copy this here. Call it get random move. Actually, let me actually search this. Web worker. Load TensorFlow.js model. Sorry, I want to use the what do you call that? This function. Sorry, back to game. Load. Where was it? Load layers. Okay, let's put it in quotes. Or actually, let's put this one in quotes. Quotations. Oh, you can just do it like this? Like you don't have to put it in a function? Okay, great. tf.load layers model. Oh, but we have to change the path. The path changes this time because we don't need this model directory, right? Just directly model. Dot load layers model. And then get move to game state. So first thing we want to do is convert this game state into the image stack or tensor or whatever. Actually, can I just copy this function directly? Let's look at game state, its usages, right? Let's see how game state is used here. Because the game state, as defined in BumperCoins bot, is a different type than the game state defined as connect4. Oh yeah, also, like, to answer a prior question I had a long time ago, like when I was like copying game state, I noticed some methods were like marked as static, even though they made no sense to be static, like the refresh method. So the reason why it was marked as static actually was actually intentional, because like the same type of game state in certain like entities like coins and wins and so forth are like when they're serialized by I think json.stringify or whatever, and then json.parse and some validation, maybe AJV is the validation thing I use to parse it and like catch misformed objects. But like the reason is that like once you serialize this object, only the properties, like only like the numbers, the coordinates, the actual numerical fixed point, like raw values, numbers, property, like numerical properties are stored, but the actual functions themselves are not like passed through the network. Like the wire does not, it only takes into account the numbers. So if I kind of like have a game state in the server and I call game state.refresh and I like in the server, it works if it were not static. And then I send it over the network to the client, the player's browser. And then the browser tries to like synchronize and it gets that same game state from the server and it calls game state.refresh. That will throw an error because game state.refresh is not a valid function. That's why I made it static. That's why you saw a bunch of statics, even though they made no sense. But aside from that, the object's basically the same. So let's look at the usages. Let's just review how we convert this to a suitable input for a neural net, right? Let's just have a look. So image stack, okay. We'll just see the usages of game state. So that's game state. We take car game state. Wait, is that's a bug, right? Shouldn't this be car game state or wait, how? What? Wait, what? No, it's the feature. It's the feature, right? It's the card or other player feature. Wait, let me see car game state. Okay, so basically car game state we use to get the coins, but then we don't use car game state here because we want to maintain the same property of like P1 coin, then P2 coin, P1 coin, P2 coin, P1 coin, P2 coin. So basically like when I say P1 coin and P2 coin, I'm referring to the image in the image stack, like a particular image, right? So like basically like, I guess it's game state and not cur game state because this way we basically kind of like this value stays the same, the 0 or 1, which means that like because again we have like P1 king coin, P1 non-king coin, P2 king coin, P2 non-king coin. So like there's like this kind of like this like P1's two images of kings and non-kings. Let's pretend that kings and non-kings are compressed into one image. Then the idea is that we have to like do this for all like the past k times. So it's like if you can skip every other, right, from like P1 current game state, P2 current game state, P1 previous game state, P2 previous game state, P1 previous, P2 previous. So every alternate you would get like the same like coins, but shifted a bit. So I guess that's why it's game state. I know I did some tests where I printed stuff out, but anyways. So back to those are uses of current game state. Just current game state is just kind of used there to get the coins, and then game state is just used to from here and then from here and then game state to get whose turn it is. In fact, this thing I should just kind of like move out of it if I want to be super optimized, because this is like pretty much, it doesn't change as we iterate over it. And then advanced comment, and then obstacles, we don't really find obstacles, and then, okay, fine. So now I have to search for usages of coin and usages of obstacle. Let's start off with coin. Right here, so that's coin. It comes from the gamestate.coins. So coin.is P1, fair enough, we can do that. We can do this, because coin.is P1, coin.is king are properties of the coin object, coin type in BumperCoins. Then coin chords, get discretized coordinates of coin, and coin.health. And let's look at obstacle. And after I check obstacle, only thing left is to check this discretized coordinates function. So let's go to obstacle. Obstacle, how's obstacle used? We have obstacle, and then it's obstacle.h, the height. Okay, so obstacle, obstacles, obstacle, 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 obstacle. Oh, nope, back there. Obstacle, obstacle. So now the only thing left is to check this function. Get discretized coordinates. Coin. Coin, X, Y. And that's it. Just X and Y. So all these properties I checked in the game state, and it's kind of recursively defined children like coins, obstacles. These all seem to be correct usages, which means I can just copy and paste this thing directly. Just copy that. I'm going to put this at the end. Copy, paste functions from, let's call this at BumperCoins bot net.ts. To okay, so now we have get discretized coordinates, and we use them right here in this function. Okay. So now we use them in this function, and then what's left is to actually get the prediction, right? Let's get policy and value. And I think we only care about policy unless we're actually doing the MCT, a Monte Carlo tree search, or alphabet, or some notion of search where we need the value. So input, we use that same function, then model.predict input value data, then convert tensor to policy. Let's also delete all the exports, right? Oh, wait, oops. Sorry about that. So now all that's left is to make sure that this function, to bring in this function, right? Get policy and value. Convert tensor to policy. Okay, so let's kind of check this out. Sorry about that. That's our game state. Then for each coin, we get the coordinates, and then we get move velocity from move dir, move ID. Whew, more stuff to copy over. Actually, could I just copy and paste net.ts as is into BumperCoins project? Would that cause any problems? Well, for one thing, num calls doesn't even exist on BumperCoins. I don't want to make it exist. I think copying and pasting is the way to go, actually. It's not a big deal. Game state. Oh wait, game state is P1 turn doesn't exist on actual game state, right? So this one, when we call it for the bot, so game state is P1 turn. So it's gonna always be, well, I mean, okay, let's assume that this neural network runs with just greedy. Like we just like if we take a step back, like we consider like how the net runs in our bot code. Like it's an expensive operation, so maybe we just want to run it once. Like the simplest form. Like there is no notion of is P1. Like we just like ask the bot like, hey network, give me a policy. Okay, I'll look at the policy and take the most promising move and just play that. And then 60 more ticks and repeat again and again, right? That would be the idea. So in that case, it'll always be player 2's turn. So this one would be false, which means this thing would become 1. So coin is P1. So if this coin is player 1's coin, sorry, this thing right here, game state that is P1 turn, is going to be false because it's player 2's turn. Okay, good. It's time to copy this function. False. Oh wait, no, it's different. It's actually this thing is changed. Like that. Yeah, like that. Game state get coins per player, and then this one right here. Like I said, those are two only usages. Should I actually put these comments in the in this copy paste? Okay, just a nice comment there. Okay, so now now we've made some progress, but now we need this function, right? So like basically everything I copied ultimately hinges on this function. And this function, again, we don't have this. So like, let's see what else we're missing. We have this function here. So we need this. We need this function right there. And then we need to import the policy type too. Okay, so this num rows and num columns is let's just hard code that. I mean, we know what it is. It is number of rows is 15. The number of columns is 20. Because again, those fields aren't defined in BumperCoins. Number of columns is 20. So number of columns is 20. And number of rows is 15. And number of columns is 20. And number of rows is 15. Good. Discrepancies between state types and okay. I just wanted to compile for now. Convert tensor to policy. Oh, we need a policy. So okay, anyway, so back here, so like we need to get move velocity, then move, and move ID is not native to BumperCoins, so that will have to be deleted, I think. But anyway, so we need to get that. So let's just get this function first. This we have, get move velocity from movedir. Delete this export nonsense. Num move dirs is not defined. Just like that. I have to delete the move IDs because that doesn't, because it's just coin ID and then those. Okay, so now I have to import policy. Okay, let's see if these are compatible. I don't think it's compatible. Because I know Move doesn't have a clone, or does it? I don't think Move has a clone in BumperCoins. Okay, let's just kind of CP that. To front-end client. Policy.ts, like that. Then v front-end client policy.ts. And let's just delete this whole clone thing. Or comment it out. We just drink some water, be right back. Actually, why am I doing this? Actually, no, instead of convert tensor to policy, let's just call this. Let's just call this our get move, right? Actually, wait, no. Get move. Get move. Just get move on game state. Okay, so we don't need any of this this validated bullshit. Positive tensor is the prediction of 0. Delete that and put it into here. Let's call the sum let max prob number equal to, I don't know, it's -1. Let move with max prob number, or sorry, move to just make this get random move. At the end, return move with max prob, and then if move prob is greater than max prob, to the tie breaks. Okay, like that. That's this kind of trivial edge case. Rid of that. Something like this. I think we're almost done. I think we might be done. I think that's it, right? Like, I think in theory, I mean, we're gonna see compile errors probably, but this is basically like, this should be overall it. Now for the moment of truth, like I'm gonna say 50 compile errors. Or actually, Okay, good. Now for the moment of truth. Okay, 21 errors. Okay, that's actually okay. All right, I'll take that. That's what I was thinking. Okay, first we have to import TensorFlow, so let's just do that. Oh. Interesting. Okay, still errors. Oh, num channels is okay. Okay, 21. I'm seeing 21 a lot. Okay, 15 errors, good. Okay, preve game state. Oh. Oh. Uh. Hmm. Well then. Hmm. That is a valid point. That it doesn't have a previous game state. I think what I could do is like kind of like kind of keep a snapshot of like oh, like pass in a game state and then pass in a game state like 30 ticks before. So we can do that. Right? So that's previous game state. Then policy 95. Okay. Let's start off with the first one, 16. Right now, I just want to get these compilers to go away. Just pretend that we have it passed in. So if k equals to 0 the first iteration, then we go prior. Or else we just keep it the same, because if k equals 1, then it's just the same. Okay, I think that should do it. Okay, let's look at the errors. $33. I'll just pass in game state. Data 0 data 1 okay. Line 99. Okay, 10 errors. Oh no. Wait, let me get my adapter. Actually, let me lie down. Okay, right. So any type, expression type 0. 102. Model predict input. So why is this working in BumperCoins bot? right? Prediction mod that predicts input. Prediction. I remember removing the type of this. Let's just add some casting just to make it work. 102. Let's do the whole thing one line. I remember seeing this one of like the early Connect 4 streams. Actually, yeah, let's see what Connect 4 does. I don't get it. How come it's not working here? Try that. So I know that's the type. Wait, no. $124. So it's not used anymore because we're only, yeah, we can delete that then. Okay. All right. All right. So now what we have to do is pass in an array of game state and something called prev game state, right? Let's just for now let's just call it do game state. In the future, let's kind of handle this link from previous. Like some sliding the window type thing. Array doc. List. Status. Models undefined. Undefined. Here. Okay, so get move, let's just do that. Do random move if not. I remember thinking about that, my bad. Actually, can you make this async? So let's return a promise of the tf.layers model. Actually, wait, no. Something like that. I feel like there's some better way of doing this. Do I have to really make everything async? Something like that, maybe? Okay, well, let's see if this works. Okay, let me track something. Okay, let's stop this for now. Okay, great. Okay, so now let's kind of go back to actually, no, wait, hold on. Option or this thing, got it. Okay. So now we have to kind of clone it, right? How do you get like pre-game state? Nope. So this one right here, from game state. ACO cloning, you have to clone every single thing in fixed point. Yeah. Just take this here. Yeah, this is really messy, but I'm just kind of copying and pasting. Right now, my main goal is just to make this work. That's all I care about. That is literally it. Make that false. Make that false. Okay, good. Swap is not found. something like that. Okay, order n. I mean, I could use like a circle or whatever, or like a. Okay, so push 3, push 8. So we're just kind of, I guess rear end means kind of here, just adding on from the end. Front, no, forget that. Just pushing. Okay, let's just push. So you add 8, 3, and then 9, and pop 3. Okay, so shift. Shift is from the front. Got it. Let's just say 32 or 31 just for some padding. 31. Or actually no, it's greater than. Okay, so if you, let's just say like it's like 4, like, or no. Then let's say 29 or greater than 30. Equal to 30. Let's just say it's greater than 30. If we have kind of been greater than 30, then past game states dot shift. So now this will kind of be a sliding window, or like it'll kind of like store any given time like some past and like kind of update it. So we're capping its size to be 30. Like the moment we exceed it, then we shift it. Kind of like that. So an spot for move would be past game states of 0 then. Something like this. That's kind of like my idea. Okay, let's see how that works. So for whatever reason, our bot is always like making these same moves. What's this arrow doing there? I want to put a debugger in the web worker actually. Hmm. Let's see what happens when this coin is dead. Then what does the bot do? Then it moves the king. Actually, wait, let me break the tie. Let me break the tie. In a max move, actually, hang on. So now we know that it's a candidate move. If it's equal, we just add it. Or else it's greater than. Like that, singleton. Okay, so now moves.max prob, and then we'll want to do a max prob, moves with max prob. If it's less than, then we get the move. If it's equal to, we just kind of add it, or else, and then finally what we want to do is kind of go here and tie break. Okay, I think that breaks the tie. Please work, please work, please work. Good. So that compiled. Okay, let's check it out. No, even with tie breaks, it's still only doing that coin. Let's put a break. Oh, so that's how you do service things. Oh, oops. I just want to close this nonsense. Just reload that. Get move. whatever. Let's just status commit initial step at integrating bot neural net with bot page. Okay, I mean, I guess that is sufficient for now. Like, I mean, we're seeing some bot being like, first is making completely arbitrary moves, and now it seems really intent on moving a particular coin. Wait, no, hold on. Let me see if I can I mean, I'm used to like hovering over it and then it's showing me like information. This debugger sucks. I mean, I don't know. Well, I mean, yeah, see, we can kind of see everything. Just gonna refresh that. Boom. Past game states of that. You know. Game state, coins. I wish there were a print function like I did for the BumperCoins bot. So this is 1, 2, 3, 4, 5, 6. The last coin is all the way here, right? At the very bottom. I mean, I can't really interpret that, to be honest. But let's kind of make sure that 0 is different. So 120, 1.26 mil and 1.26 mil and 0.94 mil. 1.26, 0.94, and then game state here. 1.27, and then instead of 94, it's 90. So there is some change. So we can see some things being different, like the coins are different. Okay. All right, whatever. Play. So every single time it's the same coin. And wait, the moves look the exact same. So why is it like, what? It's going this way or it's going that way? And no, these are two different moves. One is move direction 5, other is move direction 7. Wait, that does not make sense. Oh, I see. It's briefly hitting the wall and bouncing. Okay, yeah. So it's still always that direction. Okay, no, that's fine. That's fine. It's just the same move. Okay, so in theory, we're done then. Wait, the resize is not working? I thought this should resize itself, right? What? Oh, the resize is not... Okay. That's weird, because if you look at BumperCoins... Never mind. Okay, so in theory, I'm done. Like now the only thing left is like... Because again, like we're like... If you look at the network tab, right? If you look at the network tab and like, let's kind of like reload this bot page, then we kind of like... You see how we're getting the model.json weights.bin? Well, 304 unmodified, but like this, right? Like if we do that, we get that model.json, and then like in the binary thing, the weights.bin, and then like all we have to do then is to actually like play against the new bot, we have to just kind of use our CP command, or like go into BumperCoins bot model, like it's JSON models.json weights.bin, and copy into frontend.client. Just frontend.client is like where all the, yeah, you know, like that. And then it just it'll just kind of like give us a fresh copy of our neural of our updated network. And I believe we don't even have to actually rerun the server. Like we just have to like change the file and then it'll just like fetch the new file, I think. But anyways, yeah, like that's basically like in theory we're like done for today, right? Just to push that off stream, and then we're basically just done. Like now, like if I've done this, like if my job today, like the code I copied and pasted was correct, I wish I could debug this web workers a bit better. But like I just copied stuff from net.ts and it seems to like be running. Like if the dimensions were wrong, like the tensor dimensions in my like game state to tensor, and like put that as an input, and if the game states, like if there was some mismatch, then this wouldn't like, it would throw some exception, right? There would be some error that would be raised. So yeah, like, and then like so like it's able to like take the game state, convert it into something, and pass it. Well, not just the game state, but a previous game state too, and pass it into something, and then get some policy, and then like extract a policy like from that, like get the move with the highest. So like if I've done this correctly, and I will have to like review my work, then in theory, it's done. And all we have to do now is just create a stronger bot, and we'll create a stronger network. Create a stronger network, not create a stronger bot means create a stronger network. Just run AlphaZero a whole bunch on the network and then play against it, and it should, in theory, just become stronger and stronger each time. So yeah, I guess that's all for now. But I feel a lot happened, and I'm a bit uncomfortable with like how much happened. So maybe I'll have to like go back and like just kind of like step through, or like kind of like maybe I'll go off stream, like try to use Chrome or a different browser. I feel like I mean, I'm not sure. This whole web worker debugging experience kind of sucked, I feel. So I may have to like, I don't know, I may have to like re-look into things, make sure I'm doing everything correct. Like this game state previous. Actually, let me just. So prev game state, what do? We have the prev one, and then this one. If coin.isp1 is false, oh, I could just do exclamation mark coin.isp1, like not coin is p1. That's a better way than doing equals false. That's pretty weird, but anyways. So if this is not p1, then it is, so if it is p1, or no, if p1, if it's not p1, that means false equals false. It's player 2, then we put it in 0, or else we put it in 1. Yeah, okay, yeah, because that's current. So player 2 becomes current. Okay, yeah, so then this whole pre-game state nonsense is a... So 0 is the game state, and then 1 is the... Yeah, so that's 0 and that's 1, which is the correct order. First get current, then previous. In the bot.ts file, we actually post a message to this guy, like pass it into e.data. Then pre-game state, we pass in a second, the first like 0th and 1th. So then like game state like that, they line up. Then this one goes here, that's its usage. And that's it, right? Just these 4, that's all. So then make sure this is used correctly. Prev game state is just game state, and then we kind of use it here. So num game states is 2. So now let's say k is between 0 and then 1, and it's 0, 1, and it ends. So when it's 0, then what do? We build our image, and then we advance, and k is 0, correct. So then we go to prev game state. And then the next time current game state refers to this one, and then we build the image, but we build it from the previous game state's coins the next time. And again, this current other player still always would respect it from the perspective of current being player 2. So that's it. So in future tree search things, when I'm looking ahead, I will probably have to implement like a custom game state object, or add the maybe like a different game state object which has a notion of whose turn it is, or like a tuple with like a pair object or something. But for now, I mean, I don't know. I should try this in different hardware too. Like right now, like everything just takes like 1 or 2 like really fast, just 0 ticks, 1 ticks or whatever. But if I try on like a phone, or like maybe like a shitty Chromebook or something, I'll expect this number to be much larger. So we can't assume that like it's gonna be fast, because like this is a nice MacBook, so it's like, yeah. But anyways, and as you can see, every single time it's deterministic. Like always it'll take this thing, it'll try to launch it like 45 degrees below the horizontal, like this way. So yeah, that's, yeah, so that's that. Yes, so in k is 0, then we just kind of use current game state refers to game state. Then when k is 1, then we are in like, it'll point to the prev game state. So we use the prev game state's coins, and I think that looks correct. And once it's 1, then it doesn't matter what we advance to, and it'll be advanced to itself because k is no longer greater than k is no longer less than, like, 2 is no longer less than 2, so then we're done, 0, 1. So that's all. So I think that's good. I mean, I feel like everything is done. I think everything is done. Now all that's left is to start training, right? Yeah, a lot happened today, this stream, so I do feel a bit uncomfortable. I mean, we'll have to go over and, like, kind of review the changes myself, but and then maybe give some updates. But if I'm not wrong, then all that's left is to just train and get the model to be stronger. So yeah, I'll just end now.